Well, hi there. This is lesson 63, Saxon Algebra 1/2 through 66. Here we go. Lesson 63. Let's start with that one. This has to do with what they call changing rates. Rate, again, rate is generally considered, that's approximately equal to speed. Okay, so if I go 5 miles per hour, that would be my rate. I can also have something else. I can say I eat 12 donuts per minute. Okay, that's also a rate. That's a lot of donuts. But anyway, it's a rate. Generally, it's something over time. Something you do over time is what we call rate. Most often we talk about speed, how fast you're going. But we can also say how fast you're going, like how many donuts can you eat. That's fast. That's a lot of donuts. That's really fast. So rate and speed can relate to travel, but it also can relate to other things. So here's what you're learning in this particular lesson is if you have a rate and somebody doubles it, that means your rate is double. Let me give you an example. Okay, I'm going to say, this is directly from your book on page 201. It says, a machine can do 500 bottles in 2 hours. So in this case, notice we're not talking about miles per hour, we're talking about bottles per hour. So what's the rate is the question you ask. Well, it's going to be 500. I'm going to use B for bottles and over 2 hours. And I can reduce that to 250 bottles per hour. Okay, pretty simple. That's what a rate is. Now, you're going to be asked the question, what if you triple it? Well, that means you take your rate, 250 times 3, and that's going to give me 750 bottles per hour. That's really what your homework is about. Is they'll give you a statement of a rate. You have to turn it into a fraction, reduce the fraction, and then they'll tell you to do something with it. Cut it in half, triple it, times 10, whatever, and this will give you the new rate. So you'll have an old rate, and your goal is to turn it into a new rate. And it's not just simple where you just do it in your head. You kind of have to do a little math, then you have to do a little bit more math. And that's it. So for example, I'll give you one of your practice problems. I'll do it for you, with you. And this is practice problem A in your thing. It says, Jim drove 120 miles to his grandmother's house in 3 hours. Notice I always write this down as I go. So in your head, you're going, well, what can I do with that? Well, 120 miles over 3 hours is 40 miles per hour. Okay, so that's his rate. That's his speed. Okay, now the question is, it's not what it's asking. The question is, if he increased his speed by 10 miles per hour, well, plus 10, he's going to be going 50 miles per hour. Okay, so now you have one other little thing. So now I know his new rate, yay, and he's saying, how long is it going to take him to drive home? So he's going there. He's 120 miles in 3 hours, and to his grandmother's house. Well, she's 120 miles away. It takes him 3 hours. He goes 40 miles an hour. Yay. Now he's going to go 50 miles an hour coming home. So if he's going 50 miles per hour, okay, and he's going 120 miles, how long is it going to take him to get there? Well, notice I have 50 miles per hour, or I can write this as 1 hour is 50 miles. These are two ways to write the rate. 1 hour is 50. Now, what I'm going to do is use my concept of unit multiplier. I'm going to use this one because I know that 1 hour, 50 miles, if I multiply that times 120 miles, because that's how far he goes, notice the miles will cancel, and I will end up with something in hours. So I end up with 120 over 50, which is 2.4 hours if I did the math on a calculator. But I didn't do it in my head, so I did it in my head. So 2.4 hours. So what you're going to do, let's redo this again. They will give you some information. You will then have to change the rate to get new information. Then you're going to have to take the information you know. You have two ways to write your rates, and then figure out what you're going to unit multiply times what to get the answer. And again, your goal is think about what they're asking. If they're asking for hours, remember, what you have is on top, what you want to get rid of, you put on the bottom, and then those will cancel. I'll do one more here to help you. Let's see. I'll do practice problem B, just because. It says, Margot could pickle 500 cucumbers in 2 hours. Okay, so what does that tell me? Well, that means it's 250 cucumber per hour. All right, so let's stick with that one. And says she got tired and she reduced her rate by 1/2. So now she's only doing 125 cucumbers per hour. Okay, now how long would it take her to do 2,000 cucumbers? Well, so she can do 125 cucumbers per hour in 1 hour, or I can say 1 hour is 125 cucumbers. So I'm going to multiply one of those times this number. And I'm going to use this one. 1 hour times over 125 cucumbers times 2,000 cucumbers. Notice the C's will cancel. And so I end up with 2,000 over 125. And do the math in your head or with the calculator, and that's going to be about 8 hours, I think. So anyway, do the math. That's how many hours. 5, let me do that. 125 times 10 is going to be 1,250. Sorry, I'm on the 750 left. So that's 10 and 750. 125 times 6. Yeah, 16 hours is going to be what it is. So I would just do the calculator. What's 2,000 divided by 125? And you'll end up with 16. Don't have to do that in your head. And that's lesson number 63. Let's move on to lesson number 64. Lesson 64 is all about semicircles. And pretty much it's just a formula lesson, lesson 64. So I'm going to remind you, if you have a circle and a radius, the area is try that again. The area is pi times the radius squared. Okay, so if this was, say, 3, the area would be pi times 3 squared, or 9 pi. If I did that with the calculator, it's going to end up being 9 times 3.14. It would be around 29. Okay, but we can leave it as 9 pi. That's area. If I want to know the perimeter of a circle is 2 pi r. So in this case, it would be 2 times pi times 3, or 6 pi. And that's around 18. So if this was in inches, this would be 9 pi inches squared. If this was in inches, this would be 6 pi inches. Or in other words, somewhere around 29 inches squared. In this case, this would be around 19 inches long. And do that with a calculator to get these numbers. Don't do it in your head like I just did. So that's basically it. Reminder of what it is. Well, what if it is a half circle? So not a full circle, but half. Well, what do we do? Well, let's just see. The area is pi r squared of a full circle. Divide that by 2. That's all there is. Okay, so it's just half of a regular circle. The perimeter, I'm going to call that PER, is 2 pi r of a whole circle. Divide that by 2. Notice the 2's cancel. So the perimeter is just pi times the radius. These formulas you need to know of a half circle. half circle is called a semicircle. Semi is half circle. That's it. If I want to know the perimeter, we don't say perimeter of this. Actually, what we say is we call this the arc length, A-R-C, length. Okay, because I'm not talking about this piece too. So this piece is just half of a hole. That's the hole, divided by 2. So these are the two formulas that you're looking for. So in lesson 64, bottom line is semicircle, area, pi r squared over 2. The arc length is going to be just pi times r. Those are the two formulas for lesson 64. That's all there is to it. And then you'll have some problems where they will give you something like, here's the thing, here's the thing, here's a thing, and a thing. And they'll do kind of dashed line through this one, and they'll say this is the radius is 5, and this one's 10, and this one say 15, and this one say 11.2, and they'll say what's the area? Well, you got to find the area of this piece, the area of this piece, and the area of this piece, add them together. Or they'll say what's the perimeter? Well, you got to find that piece plus that piece plus that piece plus that piece plus the half circle, the arc length. And that's how you do it. That's lesson 64. Let's move on to lesson 65. Lesson 65 is similar to one we did last week, talking about proportions with mixed numbers. And if you remember, mixed numbers are kind of lame. We hardly ever use them. But in the context of the homework this week is they're going to introduce the concept of similar triangles. So this is lesson 65. Okay, again, 2 parts is proportions, and then the second part is proportions in the context of similar triangles. Okay, so let's do a review of the first one. So you'll have a problem with something like 1 3/4 over 2/3 is equal to 5 1/4 over x. Okay, if you remember last week, we never do these things. They're just ugly. We always turn them into regular fractions. So 1 times 4 is 4 plus 3 is 7/4 over 2/3 equals 5 times 4 is 21/4 over x. Okay, so these mixed numbers here and here, we just don't do. So we turn them into regular fractions. Then, if you remember the move swap concept, or the cross multiply, if you want to call it that concept, if I want to find out what x is, I just need to get x by itself. Now, the easiest way to do that for me is I'm going to move it over here and swap with the 7/4. So it's going to be x is equal to something over 7/4. So I'm going to swap these two. I'm going to move this one over here, and there. Okay, and so that's going to be my answer. Well, I'm now going to do the problems, and notice I'm going to do this top part first. It's this over that. So what is this? Well, 20, I'm going to think about it this way, write a little bit different. 2/3 times 21/4. Can I reduce that? Yeah. 21 over 3 is 7. 2 over 4 is 2. So I end up with 7/2 on the top and 7/4 on the bottom. Okay? So now that's 7/2 divided by 7/4. But we never divide fractions by fractions. We turn that into 7/2 times 4/7. 7s cancel. 2 goes into this twice, and I end up with 2 is the answer. So x equals 2. So it's a complicated version, but it is just step by step. You can't do it in your head. First step, change these to mixed number, or to improper fractions, if you want to call them that. Next, do the top, simplify it, do the bottom, and then if you're going to have top divided by the bottom, which is top times the reciprocal of the bottom, and then answer. Okay, so that's proportions, half of this lesson. Well, let's do part B, which is in the context of similar triangles. So this is a new concept, not complicated, but new. So let's say you have a triangle, and it has the exact same shape, but it's bigger. There. And I tell you that it has the exact same shape. How do I tell you? What we do is we look at the angles. We represent angles with these little circly things. This is a 90 degree. This is a 90 degree. We show this has one little line on it, and this has one little line on it. That means these are the same angle. 2 lines on this one, 2 lines on this one. So every angle here is the same. That means they are similar. Okay, now if I give you something like this is 3, 4, and 5, and then I say, well, this one is 9. What's that one? Here's where your proportion concept comes in. Because they are similar, I know 3 is to 4. This ratio, 3 is to 4, is the same as 9 is to x. You see that? The same 2 parts of similar triangles, the ratios between those are the same. This size to this size is the same as this size to this size. And then I do the same thing. I'm going to swap these, x and 3. I'm going to move the 4 over there, and I'm going to end up with 9 goes into 3 3 times, so I end up with 4 times 3 is 12. So x is 12. And I found that by using proportions. You can do that with any kind of similar triangle, is that you have one side to the next side is the same. There's several examples in your book on lesson 65. Just look at them, and you also have a couple of problems. Problem number 14 has 2 of these as well. And that's lesson 65. Okay, lesson 66, last lesson for the week. Lesson 66. Okay, lesson 66 is about ratio word problems. Again, these are proportions. You've done these before. It's just now putting them in word problem form. So, for example, do one from your book. And this one's on page 209. And it says, okay, the ratio of number of wrigglers to squirmers. So wrigglers is W, squirmers is S. So this is the ratio of wigglers to squirmers. I'm going to write that as a fraction. Wigglers over squirmers. That's what I mean by this to that. It says that's going to be 13 to 2. Okay? Well, that's the same as, well, what if you have 26 wigglers? The question is, how many squirmers is there? Okay, I'm just going to call that one X. And I do the same thing I did before. I'm going to swap these. And I'm going to move the 2 over here. And I end up with 52 over 13, which is 4. So X equals 4. And that's the answer. So you're going to have a word problem, and you're going to set it up as a ratio. So I'm going to give you one more example, and this one is your practice problem. So this is practice problem A. So it says the ratio of Holsteins to Charleys, those are cows. So Holsteins, I'm going to say is X, to Charleys is going to be 22 to 3. Very expensive cows, those Charleys. So it says, well, if there were 3,000 Charleys, how many Holsteins would there be? Okay, that would be my X. That's my equation. So I'm going to just make this 22 over 3, and then I'm going to move the 3,000 up here. and that'll give me X. 3,000 over 3 is 1,000. So 1,000 times 22 is 22,000. That's how many Holsteins I've got. So that's what you're going to do, lesson 66. And we are done. See you next week.